speed at a sufficient threshold breaks the curve of conventional threat assessment entirely. A hypersonic glide vehicle does not merely fly faster than the systems designed to engage it. It arrives at its target, while the defensive system is still determining whether the track is real. The difference between a weapon that can be intercepted and one that cannot is, in the calculus of modern air defense, the difference between a threat and a certainty. The facility beneath the flight line of Omidiyeh Air Base in Khuzestan province was not producing hypersonic systems. Iran did not yet possess the manufacturing base for that. What it was storing were the hypersonic boost-glide reentry vehicles that had arrived through a procurement channel the intelligence community had been tracking since the first anomalous cargo movement appeared in the collection record 22 months before the targeting decision. The stockpile represented the single largest concentration of this capability the intelligence community had localized. Eliminating it would not eliminate the capability. Other vehicles existed at other sites. It would eliminate the operational reserve that gave the IRGC missile command the confidence to consider massed employment, the scenario the regional threat assessments had been describing as the threat existing defensive architecture could not reliably address. Removing the reserve that made massed employment viable was the objective. Omidiyeh Air Base sits in the flat agricultural terrain of central Khuzestan, close enough to the Iraqi border that its operational history includes roles in every significant conflict that has moved through the Western theater since the base was constructed. Its surface infrastructure, runways, hardened aircraft shelters, fuel storage, maintenance facilities, is thoroughly documented in open source material. What was not documented was the construction activity that had occurred beneath the base's primary weapons storage apron over a period of 7 years, using the base's routine infrastructure maintenance program as the surface explanation for the equipment movements and excavated material disposal that underground construction of the required scale necessarily generates. The underground facilities sat at a depth that reflected a specific engineering calculation, deep enough that the base's own operational activity, aircraft landings, ground vehicle traffic, the vibration environment of a working military airfield, would not compromise the environmental controls that the stored vehicles required, and deep enough that the defense architecture's designers had calculated no available penetrating weapon could reliably reach while the base's surface defenses were intact. The depth was 49 meters. The substrate was compacted clay over a dense limestone base, a geological profile that had been selected as much for its bearing capacity under the construction loading as for its penetration resistance. 49 meters of compacted clay and limestone was not the deepest facility the B-2 program had been tasked against. It was, however, defended by a surface air defense architecture whose density reflected the base's status as an active operational installation, a density that made the approach geometry for releasing aircraft more constrained than any previous mission in the series. Omidiyeh's defense was not the layered, purpose-built architecture of a nuclear facility or a buried command post. It was the defense of an operational military air base oriented toward protecting aircraft and infrastructure from the kinds of threats that active air bases face, which are different in character from the threats that underground storage facilities face. The difference in orientation translated into a defense that was denser at lower altitudes, the Tor M1 and Panzer systems that covered the traffic pattern and the approach corridors, and thinner at the altitudes and ranges that a high-altitude releasing aircraft required. The thinness at altitude was not an oversight. It was a resource allocation reflecting a threat assessment that had not included a B-2 strike as a planning scenario that required specific counter-capability. The defense had been designed against the threats the base's planners believed they faced. The target folder's planners had studied what they believed and designed the mission against the gap between that belief and the threat the base was actually facing. The gap was real, but narrower than the planning model showed. The base's 2 Hawk batteries, legacy systems kept functional through 3 decades of sanctions by indigenous reverse engineering and third-party procurement, were positioned to partially compensate for their age-limited performance envelope. Their maintenance status, software revision level, and fabricated component parameters were all estimated rather than measured. Estimated parameters produce wider confidence intervals. Wider intervals meant the EW allocation had been sized against the upper bound of Hawk capability rather than the mean consuming budget that a more precisely characterized system would not have required. The mission was a single B-2 Spirit, carrying 2 GBU-57 massive ordnance penetrators, one for the primary storage vault, one for the environmental control infrastructure housed in a secondary chamber 50 meters away. Destroying the vault without destroying the environmental controls left a recovery pathway. Partial salvage from vault sections, the first weapon's overpressure did not fully reach, under conditions that sustained serviceability. Both chambers required a weapon. The employment solution placed 2 releases on diverging headings, timing compressed to the minimum that kept the first detonation from affecting the second weapon's GPS solution accuracy. The minimum was 63 seconds. At 8:19 p.m., the B-2 lifted off from the forward operating location. The routing to Omidiyeh from the forward location required 10 hours and 47 minutes, the shortest flight time of any mission in the deep penetration series conducted against Iranian facilities, a function of Omidiyeh's position in the southwest of Iran within range of Gulf-based staging. The shorter flight time compressed the fatigue management challenge from a marathon into a middle-distance event. Not easy, but qualitatively different from the 14 and 21-hour profiles of previous missions. The pilot noted the difference and filed it as irrelevant. The release point was at the end of the flight, regardless of the flight's duration, and the performance standard required at the release point was the same, whether the aircraft had been airborne for 10 hours or 20. He managed his energy accordingly, treating the shorter sortie as requiring the same physiological discipline as the longer ones because the release point did not know how long the flight had taken to reach it. The tanker contact at 11:43 p.m. completed in 13 minutes. The pilot held position through a wind shear oscillation by correcting before it fully developed rather than responding after. The kind of anticipatory control that separates experienced receivers from less experienced ones. The tanker departed south. The B-2 continued toward the Gulf Coast. The EW package activated at 5:47 a.m. local time, 39 minutes before the penetration corridor entry. The package was configured for the specific challenge that Omidiyeh's defense architecture presented. The Hawk battery's uncertain performance envelope had driven the allocation toward a broadband suppression approach rather than the precision frequency targeting that characterized previous mission EW packages. Broadband suppression against an uncertain target used more total power to achieve equivalent effect, power that was drawn from the allocation available for the more precisely characterized systems. The Tor M1 and Panzer systems in the inner ring received narrower frequency margins than planning preferred, adequate by the planning cell's assessment. The pilot, reading the EW section of the mission brief, had noted the word adequate and had asked in the briefing what adequate meant in quantitative terms. He had been given the quantitative terms. He had filed them and continued. The S-300 battery that provided the sector's long-range coverage was positioned southeast of Avaz at a bearing from the mission's approach corridor that placed it at an unfavorable aspect for detecting the B-2's approach vector. Unfavorable aspect meant reduced radar cross-section due to geometry rather than stealth design. The B-2's signature from specific angular aspects is lower than from others, a function of its planform shape, and the Avaz battery's position placed the aircraft in a low return aspect for the approach geometry the mission was using. The Growler flights had primary suppression allocated to the S-300, regardless of the aspect advantage, treating the favorable geometry as margin rather than sufficiency. Margin was used in this mission architecture the same way every margin was used in this mission architecture, completely. At 6:13 a.m. local time, 9 minutes before the planned penetration corridor entry, the signal's intelligence feed showed the base's alert posture elevating, not to an active threat response, but to the heightened readiness state that the Iranian Air Force cycled its operational bases through on irregular schedules as an operational security measure. The elevation was characterized as a scheduled readiness cycle, rather than a threat response activation. The distinction mattered because a scheduled readiness cycle elevated the operational tempo of the base's surface defense systems without necessarily activating their fire control radars. It increased their manned status and scan frequency while keeping them in search rather than engagement mode. Fire control radar activation required a contact report. A contact report required a detection. The mission's EW architecture was designed to prevent the detection. The readiness elevation made the prevention more important by placing more operators at more consoles at higher alertness levels, increasing the probability that a marginal return above the noise floor would be reported rather than logged and set aside. The marginal return occurred at 6:29 a.m., 4 minutes after the B-2 entered the penetration corridor. One of the two Hawk batteries, the eastern battery, positioned to cover the approach axis the mission was using, produced a single acquisition sweep return that the battery's operator assessed as marginally above the system's detection threshold. One return. The Hawk's fire control radar was in search mode, not track mode, and a single return in search mode does not constitute a track. The operator was sitting at an elevated readiness state that the scheduled cycle had produced, which meant his reporting threshold was lower than baseline. He reported the return to the base air defense controller. The report was accurate. One possible return, single sweep, above threshold, confidence low. The base air defense controller received the report and faced a decision shaped by two simultaneous conditions. The anomalous EW environment his sector had been experiencing since 5:47 a.m. across multiple frequency bands, and a single low-confidence return from one of his two Hawk batteries. The EW environment alone was not a contact. The single return alone was borderline. Together, they occupied the specific category of ambiguous evidence that air defense doctrine addresses with a risk-weighted response. When two independent indicators suggest a possible penetration, and neither alone meets the engagement threshold, the doctrine's answer is to elevate the defensive posture and actively seek confirming evidence, rather than to authorize engagement on insufficient data. He elevated the sector to active search alert and directed both Hawk batteries and the Tor M1 inner ring to maximum scan rate. He did not authorize fire control radar activation. That required a confirmed track. He was looking for a confirmed track. The active search alert reached the Tor M1 battery on the northern perimeter at 6:31 a.m. The battery elevated its scan rate. On the third sweep at maximum scan rate, the Tor M1's acquisition radar produced a return that its tracking processor assessed at 38% detection confidence, below the engagement threshold, above the reporting threshold. The operator reported it at 6:31 a.m. and 44 seconds. The controller now had two systems, the Hawk and the Tor M1, each reporting a single below-threshold return on the same general bearing, separated in time by 2 minutes and 19 seconds. Two systems, one bearing, two separate detections. His doctrine told him what to do. He authorized fire control radar activation on both Hawk batteries at 6:32 a.m. The fire control radar activations appeared on the B-2's passive warning receiver at 6:32 a.m. and 7 seconds. The mission commander assessed the display in the time it took to register. Two Hawk fire control emitters active, bearing consistent with the battery positions he had memorized from the mission brief, range placing the aircraft inside the Hawk battery's theoretical engagement envelope based on the upper bound performance estimate that the EW allocation had been sized against. Inside the theoretical envelope at upper bound performance, the Growler EW officer's broadband suppression was running against the Hawk fire control frequencies, but broadband against an uncertain target at upper bound performance left a margins that the mission commander was now measuring in seconds rather than in abstract probability assessments. He was 4 minutes and 11 seconds from the first initial point. He transmitted the priority reallocation code to the Growler flight. The EW officer received the code and redirected available power from the outer suppression allocation, the S-300 coverage, to the Hawk fire control band. The redirection reached full effectiveness in 6 seconds. The Hawk battery's fire control pictures degraded. Both operators reported jamming on fire control frequencies within 4 seconds of the degradation reaching their displays. The eastern battery, the one whose single acquisition return had initiated the entire sequence, attempted the frequency shift its training prescribed. The Growler was 2 seconds behind the shift. Those 2 seconds produced one fire control sweep on a clear frequency. The sweep returned a contact at 51% detection confidence. 51%. The automated engagement system displayed a red contact symbol on the eastern battery's fire control console, above threshold. The operator had an authorized engagement. His hand moved toward the launch authorization panel. The Growler's suppression reached the shifted frequency at that moment, not in time to prevent the red contact symbol, but in time to degrade the fire control solution before the operator completed the engagement sequence. The solution that the fire control computer was computing when the jamming degraded it was incomplete. The range ambiguity that a single sweep could not resolve had not been resolved by a second sweep before the jamming restored. An incomplete fire control solution produces a weapon that will fly toward a bearing at an uncertain range, detonating its proximity fuse when its seeker detects a return consistent with its target profile or when its time of flight limit expires. The operator looked at the incomplete solution indicator on his display. His training was explicit. An incomplete solution launch was authorized only when the engagement controller specifically authorized it. He keyed his controller. The controller assessed an incomplete solution launch against the current engagement geometry, a bearing toward a sector where his own air base's traffic pattern existed, where a fire-and-forget weapon flying on an incomplete solution could, in an unfavorable trajectory, produce a result that no air defense engagement should produce. He denied the incomplete solution launch and directed the battery to hold for a complete solution. The Growler's suppression continued. The complete solution never arrived. The Eastern Hawk battery held. The fire control symbol on the operator's display cycled from red to yellow as the tracking processor downgraded the contact from confirmed to unconfirmed under the sustained jamming. The contact did not reappear on subsequent sweeps. The operator sat at his console with the specific quality of professional frustration that comes from watching a contact disappear while holding an incomplete solution authorization that was never completed. He logged the engagement sequence precisely, including the incomplete solution indicator and the controller's denial. He had done everything correctly. The aircraft was already past his engagement envelope. The first initial point was at 6:34 a.m. The bay doors opened. The first GBU-57 released from the forward station. The aircraft corrected and turned onto the 63-second, heading toward the second aim point. Bay doors closed. The weapon's descent through the compacted clay above the primary storage vault proceeded at the rate the geological survey had predicted. The clay's deceleration profile was consistent with the fusing algorithm's model. No anomalies, no density variations outside the survey's uncertainty band, no surprises in the material transition to the limestone base layer at 31 meters. The algorithm counted through the clay, registered the limestone transition, counted the prescribed additional depth into the limestone, and fired at 47 meters, 2 meters above the primary storage vault's ceiling, at the position the engineers had computed as optimal for transmitting the detonation's overpressure into the vault interior through the limestone rather than detonating inside the structure. The limestone transmitted the overpressure into the vault with the efficiency that its acoustic impedance characteristics predicted. The stored hypersonic glide vehicles, the precision-guided reentry airframes whose procurement had taken 3 years and whose operational significance had driven the targeting decision, experienced the pressure event at a magnitude the engineers had computed would exceed the structural tolerance of their guidance assemblies and thermal protection systems by a factor that left no serviceability pathway. The vehicles were not destroyed in the sense that munitions are destroyed. Their structural integrity was compromised at the level of the precision components, whose tolerances were measured in microns. Components measured in microns do not survive overpressure events measured in megapascals. The vehicles ceased to be weapons. The second weapon released at 6:35 a.m. and 3 seconds, 63 seconds after the first. Its aim point was the environmental control chamber, 50 meters from the primary vault, on a heading that the targeting system's GPS solution had been computing continuously since the first release. The weapon followed its terminal guidance to the subsurface coordinate and detonated inside the service tunnel that connected the environmental control chamber to the primary vault, at the position the target folder had identified as producing simultaneous overpressure effects in both the environmental chamber and the residual vault space through the shared tunnel connection. The environmental control infrastructure, the precision climate systems that had been maintaining the stored vehicles within their operational tolerance envelope, was eliminated. Whatever had survived the first weapons pressure event, in peripheral sections of the primary vault, lost the environmental conditions that defined its serviceability. The temperature differential between the operational tolerance range and the ambient limestone formation temperature is not dramatic. Over the hours following the environmental system's elimination, the differential was enough. At 6:36 a.m., the base's internal monitoring network registered loss of contact with the underground facility's environmental monitoring sensors. The sensor network had been transmitting temperature and humidity data from the storage vault on a continuous basis. The monitoring architecture that the operational protocol required to verify the stored vehicles remained within their tolerance envelope. Contact loss triggered an immediate alert to the facility duty officer. The duty officer attempted restoration through the redundant monitoring channel. No response. He attempted the facility communications link. No response. He activated the emergency protocol and notified the base commander at 6:38 a.m. The base commander, whose sector had just experienced an active search alert involving multiple Hawk battery fire control activations and a suspected airborne contact that had disappeared under jamming, understood the relationship between the two events by 6:41 a.m. He transmitted the combined report to his command chain at 6:43 a.m. The report described, in the language of operational military reporting, the sequence of events that had occurred over the preceding 32 minutes. The sequence was complete and accurate. What it described had already happened and could not be reversed by any response the command chain could generate. The B-2 was 270 miles into its egress when the base commander transmitted his report. The data link confirmation code had been sent at 6:37 a.m. The planning element that received it noted the Hawk engagement sequence and began the post-mission assessment of the Eastern Battery's incomplete solution authorization, the mission's closest exposure point. The assessment would note that the controller's denial had been the correct procedural decision. It would also note that the correct procedural decision and the mission protective decision had been the same decision on this occasion. That alignment was not guaranteed. It had been real. The numbers that closed the package: 10 hours and 47 minutes of flight time. 2 GBU-57 massive ordnance penetrators employed in a 63-second sequential interval on diverging headings. 1 Hawk battery single acquisition return that initiated a cascading alert sequence across the base defense architecture. 1 Tor M1 return at 38% that provided the second independent indicator, triggering fire control authorization. 1 fire control sweep at 51% on a shifted frequency. Above threshold, incomplete solution, launch denied by the engagement controller on geometry and doctrine grounds. 6 seconds of Growler, suppression, latency on the frequency shift that produced the 51% return. 0 aircraft lost. Primary storage vault eliminated. Environmental control infrastructure eliminated. The hypersonic glide vehicle stockpile that had been accumulating at Omidiyeh for 3 years, and that had given the IRGC missile command the reserve confidence for mass employment planning, ceased to exist as an operational asset in the time between 6:34 a.m. and 6:36 a.m. on a morning that began at the base like every other morning. A weapon that cannot be intercepted derives its strategic value from the certainty it will reach its target. Remove the inventory, and the massed employment scenario that made it strategically significant requires a planning timeline that starts again from zero. That timeline started again from zero at 6:43 a.m. The apron above the vault is unchanged. The vault is not.